Okay, when you're working with inequalities, it's entirely different than working with equations. Equations are nice because you're coming up with a definitive solution where you can kind of plug numbers back in and check them. It's not necessarily an interval representation set. In calculus, we often come up with interval sets as our representation for answers, and so that's why this is so important. So you have to be able to consider a graph just like we did yesterday. Today, for nonlinear inequalities, this is the key, folks. This is what you're learning today. Nonlinear. So again, I don't just pull the stuff out of thin air. I try to build upon it. Today, did we practice linear inequalities in our checkpoints? Yes. Did we also practice something nonlinear? Yes. You had two options: make a table or make a graph. Raise your hand if you made a graph like I did during your checkpoint. Raise your hand if you did the number line test. Raise your hand if you just thought about it in your head. Okay, so there's, those are really kind of the ways. Today, you can't do anything other than make a number line and test it. That's all you can do. So for nonlinear, we're talking about something that looks like this. X over 2 is less than or equal to 3 over x minus 1 over x plus 1. Okay? And the problem is you don't know what the graph looks like, so you can't just sketch a graph. So we have to be very, very careful because the solution is delicate. And when I say that, I mean that every once in a while I'll come across, after teaching math for 12, 13 years, I should hopefully get kind of good at it, right? But still, every once in a while, if I make a mistake, sometimes it happens due to inequalities. Remember, there was a calculus problem that came up 2 years ago. I did the solution, and it was incorrect. I was like, what? And it was because I wasn't following this procedure. And I was like, oh, I don't want to go through that. I'm like, well, if I want to get it right, I'm going to have to. First, move everything to one side. So set equal to 0. When we move everything to one side, we set it equal to 0, and we're going to make one fraction. Our second step is to factor the top and factor bottom. Got it? We'll get to 3 and 4 in a second, but that's 1 and 2. Okay, so if you flip it over, you should have this at the top, right? All right, so this is the problem I'm doing from your notes. Yep, I'm going to add an equal sign today. Add an equal sign. Okay, so first step is to move everything to one side. So what do? Subtract 2. So we got 4x over 2x plus 3 minus 2 over 1 is greater than or equal to 0. Second of all, I have to make it in one fraction. What do I do to make it in one fraction? 2x plus 3, 2x plus 3. I get 4x minus 4x minus 6 all over 2x plus 3 greater than or equal to 0. What happens? Negative 6 over 2x plus 3 greater than or equal to 0. I don't like the negative. So I'll multiply both sides by a -1, and I get 6 over 2x plus 3 is less than or equal to 0. Those are the first two steps, because can you factor 6? Well, I guess 2 and 3, but can you factor like a binomial or a trinomial or something? No, so it's done. 2x plus 3, done. So it's written as one fraction, and it's factored. We move on to steps 2 and 3. We go to set up our interval. We make a number line to do that. And on our number line, blah, 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 on our number line, we place the zeros from the top and the bottom. So make a number line and place your zeros. Second of all, we set up a table, and the table has rows and it has columns. The number of columns is equal to the number of zeros plus 1. The number of rows is equal to the number of factors in the top and the bottom. We're going to do those two steps. We're going to make a number line. We're going to put our zeros on top, and we're going to make a table. The number of zeros plus 1 for columns, and then the number of rows is number of factors. So let's do that. Make a number line. On my number line, I plot where the top is equal to 0. Is the number 6 ever equal to 0? No. So there's no 0 for the numerator. Is the denominator ever equal to 0? For what value? Negative 1.5 or negative 3/2, right? So I solve the denominator equal to 0, I get negative 3/2. That's the only number I have to plot. Negative 3/2. Below that, I make a table. In my table, the number of columns is equal to the number of zeros plus 1. How many zeros are there? So how many columns will there be? And I always use this to divide it up. Okay, so 2. 1 on one side, 1 on the other side. The rows is equal to the number of factors. Here, I just have 2 factors. One is 6, and the other one is 2x plus 3. The factors are where you get your zeros from. The last thing we write down on this page is solve. You are going to test intervals for positive and negative. So somebody pick a number to the left of negative 3/2. Negative 3. So I'm going to plug in negative 3. Is there anywhere to plug that negative 3 in for 6? No, 6 is 6. And 6 is always positive, right? 6 is always 6, which is always positive. So therefore, it is positive. No matter what we plug in, 6 will be positive. Now the bottom, negative 3, when you plug that in, do you get a positive or a negative? You get a negative. Give me a number to the right of negative 3/2. 0, best number ever. Plug in 6 and you get 6. It's positive. Plug 0 into the bottom, you get positive. So do you see what we're doing? We're just simply plugging values into here to see if we come up with positive or negative. This is just a little bit more efficient of a way. For this problem, could have probably just thought about it right here. Maybe didn't even need to make a table. But for other ones we do, trust me, you're gonna want to make the table. Positive times negative. Positive times positive. This is asking me, where is it positive or where is it negative? Which one is it? It's asking me, where is it negative or equal to 0? So my solution set will be from negative infinity to negative 3. Parenthesis or bracket around negative infinity. Parenthesis or bracket around negative 3. Which is it? The equal sign says we put a bracket. Here's the problem. Wait a minute. I didn't put negative 3. Not negative 3. Come on. Negative 2/3. Okay. Oh no, confusion. Okay, negative 3 halves. Sorry. All right, there we go. Okay, negative 3 halves is our dividing point. Sorry, you guys are probably really confused there for a second, right? Okay. Yeah, the answer was neither. You don't put it as negative 3. It was testing you. Now I got negative 3 halves, and you say, I want to put a bracket because I see the equal sign. But there's a problem. If we put a bracket here, that means you could legitimately plug in negative 3 halves, and it would satisfy the inequality. If you plug negative 3 halves into here, what happens to the denominator? And you can't do that, can you? So negative 3 halves is excluded from the solution set because it would give you 0 in the denominator. How do we exclude it? We exclude it by putting a parenthesis instead of a bracket. That makes sense? Okay, so this is how we kind of lay out the problems. They're not easy. What we're going to do is we're going to do one more together as a class, and I'm going to put forward your assignment to you. And in class, you're going to do one of the easy problems and one of the difficult problems, and we're going to correct them to see how you did. It went well during third hour. I expect it to go well this hour too. We are now on this problem. No, 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 no. There you go. That's the next one, right? No, that's 48. Where is it? There we go. X over x plus 1 is less than 3x. That's the next one in your notes. What's the first step? Bring it over. X over x plus 1 minus 3x over 1 is less than 0. I have to make into one fraction. So what do? Top and bottom by x plus 1. Get x minus what? X squared minus 3x. All over x plus 1 is less than 0. Can you combine like terms together? Yep. So you have negative 3x squared minus 2x over x plus 1. It's less than 0. What? What? Take out a negative x. Yep. We're going to take out that negative x. Get a 3x plus 2 over x plus 1. I don't like the negative. Get rid of it and flip the sign, right? Okay, I just did the first two. I combined it into one, and then I made a table. Or I'm sorry, then I factored it. Now it's time to make a table. In order to do that, we first start by making a number line. What are the zeros of this problem I put on my number line? Negative 1, 0, and negative 2/3. Make sure you put them in the right order. That does matter. If I have 3 zeros, how many columns will I have? 4 columns. How many factors do I have? 3 factors, so therefore 3 rows. My factors are x, 3x plus 2, and x plus 1. Time to test. What's a number to the left of negative 1 that I can plug in? Negative 2. Plug it in. What do you get? A negative. Plug it in here. Negative, negative. What's the number between negative 1 and negative 2/3 you can plug in? Negative 3/4. Plug negative 3/4 in for x, you get a negative. Plug it in for 3x plus 2. Let's see, 3 times negative 3/4 is negative 2.25. plus 2 is negative 0.25, so it is negative. Then negative 3/4 plus 1, positive. A number between negative 2/3 and 0. Negative 1/2 is 1. Some people tried negative 1/3. That way the 3's would cancel. It's up to you. It doesn't matter. Because you said negative 1/2, I'll choose that. X will be negative. 3 times negative 1/2 is negative 1.5 plus 2 is positive. And then negative 1/2 plus 1 is positive. And then we plug in 0. I'm sorry, a number to the right of 0. 1. Positive, positive, positive. As you can see, you get a nice shape going here, don't you? These negatives and positives. It's not always like that. Got to be careful. Negative, negative, negative makes a. Negative, negative, positive makes a. Negative, positive. Nice alternating. Doesn't always do that. What's the question asking? Where it's positive or where it's negative? It's asking where it's positive. So that would be from negative 1 to negative 2/3, and then from 0 to infinity. Now, do I use parentheses or brackets? Suppose the problem from the beginning had an equal sign underneath. Somebody tell me, would I have a parenthesis or a bracket on negative 1? Why? Can't have negative 1 here because you would have 0 in the denominator. How about for negative 2/3? Bracket, because that's in the numerator. How about for 0? Bracket, because that's in the numerator. How about infinity? Parenthesis, because you can never have a bracket on infinity. Okay, so if you would add an equal sign, then that's what you would have done. You can see how it's a little involved, isn't it? Takes a little while, but you're starting to get it, right? So take out a scratch or take out a sheet of paper that you would do your homework on. Write this down as your assignment. I'm giving you a chance to do 2 of them 100% correct in class. Got it? Oh, by the way, I put a graphing calculator video yesterday up online, and today I'm going to make a video of the graphing calculator exploration worksheet. Normally we spend more time working on that in class, but with homecoming it kind of got away from us. So if you have trouble making your way through that, I'll do all the stuff for you. You just need to be able to make sure you can follow along with it. So like when I do like an intersection option on your calculator, you should make sure you have the same thing that I do. So if you're having struggles getting through that, just sit down for 20 minutes one night, watch a video, and make sure you know how to use your graphing calculator. That's the whole point. Okay, here you go. Problem 39. Write it down. You don't have to get everything on one side. You don't have to even factor it. You could go right into making your number line. It's already set up nicely for you, isn't it? So you go ahead, try number 39. Should take you about 3 minutes. Come up with your solution set. But start by making your number line and your table. That's where you start with this. It's already factored, and it's already all on one side set greater or equal to 0. I'll pause, give you some time. Okay, let's check this. We've got a number line. What numbers did you plot? Boys and girls, what'd you plot? -1, +3. So how many columns do you have? You have 3 columns. How many rows? 2. So you do x minus 3 and x plus 1. Then we start checking. I plug in a number here, say -2, 0, and 4. Okay? -2, I got a negative and a negative. 0, I got a negative and positive. 4, I got a positive and a positive. So negative times a negative is a positive. Negative times a positive is a negative. Positive times a positive is a positive. The question is, are you looking for where this is positive or where it's negative? Positive, because you got that. You're wondering where it's greater than or equal to 0. So it's going to be from negative infinity to negative 1 union with 3 to infinity. Now, you would like to put brackets, right? So we can bracket the 3 because the 3 would give you 0 in the numerator, not 0 in the denominator. But negative 1 gives you 0 in the denominator, so you have to have the parentheses. If you do that on the test, you don't get that, I take a half a point off. Sorry. Okay? Got to have that parenthesis. Here's the you got 100%. Here's the you got it, but you made just a tiny little mistake. All right, good job. Next one. This is harder. This is 48 because a lot of people made this mistake right away. What's the first step? Subtract 1. A lot of people forgot to subtract 1 right away. They're finding common denominators. First, subtract 1. Be careful. Okay, so you should have 3 over x minus 1 minus 4 over x minus 1 over 1 is greater than or equal to 0. Now, what do you need to multiply top and bottom by here to get common denominators? X, top and bottom here. Top, bottom here. So you get 3x minus 4x plus 4 minus x squared plus x. Combine like terms. X and 3x make 4x. So those will cancel with the negative 4x, correct? So in the numerator, you have 4 minus x squared. Does that factor? 2 minus x and 2 plus x over x times x minus 1 greater than or equal to 0. How many zeros do I have? 4 zeros. I have negative 2. I have 0. I have 1. And I have 2. So how many columns will I have? 5. How many factors do I have? How many rows do I have? We have 2 minus x. We have 2 plus x. We have x minus 1. You can finish it off from there, but raise your hand if you made a small mistake up in this part right here. Yeah. It'll work out the same, but 4 minus x squared factors are 2 minus x and 2 plus x. You should still get the same thing. Question. Can't use a bracket on what two numbers in this problem? So the equal sign says use brackets, right? But I can't put brackets around infinity, and I can't put brackets around 0 or 1. Because that would give me 0 in the denominator. But I can put brackets around 2 and negative 2. Not on 0 and 1. Okay, so not easy stuff. And you went through that point of confusion, but you're coming out towards learning. You have to do these two things. You have to practice it, and then you have to sleep. If you want to convert towards long-term memory, you have to practice this stuff, and then you have to sleep. You don't do one of those two things, might as well not have done today at all.